Good morning. This is lesson 10-5, trigonometric word problems. Today's learning target is I can apply my knowledge of right triangle trig by completing a word problem. So we're going to progress through this lesson rather quickly. It shouldn't take more than 10 to 15 minutes. And I'm going to give you a heads up. The word problems for this unit are actually quite straightforward. Once we do Regents Review towards the end of the year, we're going to examine complex trig problems. So those are the exact same type of problems we're studying today. It just requires us to do the trig twice. So the two main problem areas of trig word problems are identifying the angles. So we want to figure out like, how much is our angle of elevation or angle of depression? We're going to go over what all that means shortly. And how long a side length is. But the biggest issue with this stuff, and I'm giving you a heads up, the problems we're doing today are actually not as difficult as you think they will be. The hardest part is translating the sentence or the background into a figure. So we are going to be really looking at how to translate the vocabulary into the math. So the first type of thing we look at are angles. So we really focus on the angle of elevation and the angle of depression. The angle of elevation means to elevate or to move in an upward direction. So basically means goes up. Goes up like this, and that's your angle, just like here. The angle of elevation is an upward angle from the horizon. So when we talk about the horizon, we basically mean like if you're looking at the water, I'm gonna use some green water like the Gowanus Canal, very toxic. And if we look at the horizon, it's eventually going to be flat, and then we can see the object above it. It's sort of when you see the sun rise or the sun go over. This is your angle of elevation. And it's not going to be over here because we're not really looking at that. That's where your right angle is going to be. The angle of depression, grab your tissues, just means to be depressed. Or to be down. Thus, the angle of depression is the reference angle from the position in a downward direction. So as you can see, it basically just means our triangle gets flipped. So your triangle's getting flipped. But here's the thing. It's always going to be on the inside of our triangle. It's not going to be on the outside of our triangle. That's why there's a big red letter error. So it's actually quite simple. One thing you need to know is that the angle of depression is equal to the angle of elevation. So whenever they give you something where they say like, oh, my angle of elevation is this or my angle of depression is that, just know right away, boom, they're equal to each other. So always draw your angle on the ground. So we always want our angle to look around in this area. All right. Now here's the way our situations can look. Where we have our side lengths. Sometimes we want to figure out how long the wire is or how long our horizontal distance is. This is horizontal. Know that. Horizontal, vertical. I'll write a quick note because sometimes it does say what's the vertical length. Vertical. Horizontal. Sometimes you'll be asked to find the vertical distance versus the horizontal distance. Ooh, the sun. Mr. O'Sullivan loves to get the sun. Sometimes you want to find out how long the shadow is, or how tall the person is, or how long the sun's rays are. Again, these are just the situations we're going to be looking at. And it's quite explanatory. I really promise you, it's not as bad as it looks. So let's delve into the problem of trig. So we have a man standing on level ground that is 1,000 feet away from the base of a 350-foot tall building. Find the nearest degree, which means the whole number, because whenever it says the nearest degree, we want a whole number, the measure of the angle of elevation to the top of the building from the point on the ground. So let's underline or annotate our background. So I have a 350-foot tall building. 350 foot tall building. I want to measure to the nearest degree. So I'm going to write down whole number as my answer. And I want to find out the measure of the angle. I want to find out the measure of the angle. So that's going to require ka toa. But the thing is, whenever we have angles, we want to do inverse trig. Okay. And we want to find out the angle of elevation to the top of the building from the point on the ground to where the man is standing. So this is going to require SOHCAHTOA, as we said before. The first thing we want to do is draw a triangle. Oh, and look at that, I just drew a triangle. We now want to figure out that we want to label our image. So we're going to label our information. No, it's not a perfect triangle, but I'm going to draw my right angle anyway. We're always dealing with right angles. We know that our building is 350 feet tall, so this is our building. We want to find to the nearest degree the measure of the angle of elevation. What I like to do is I always like to put my angle of elevation down below. So I put my X there because the thing is we don't know what that angle is. We know that the man is standing on level ground, so he's standing on a flat surface that's 1,000 feet away from the 350 foot tall building. So 1,000, and I'll draw a little stick figure for my man. Okay. And then this just becomes a basic trig problem. The first thing we want to do is label our hypotenuse, which is across my right angle, my opposite, which is my 350, and my A for my 1,000. That's my adjacent. So now I need to ask myself, what am I dealing with? I have my adjacent, and I have my opposite. That means I am dealing with tangent. So I do tan of X equals opposite over adjacent, which means tan of X equals my opposite of 350 over my adjacent of 1,000. And now I only have one more step. I take the inverse of both sides. So I get X equals tan to the -1, or arctan or inverse tan of 350 over 1,000. So you would need to type this into your handy dandy calculator. And remember, we need to be in degree mode. So if you don't have a graphing calculator at home, that's completely fine. You can still do this on Desmos. So I'm going to do second tan 350 divided by 1,000. And I get 19.29, which I just round to 19 degrees. That is your final answer. So it's basically saying that this angle right here is 19 degrees. Okay, so now for my second example. If you were struggling with the first one, I would do this one with me. If you were like, okay, that actually wasn't that bad, try this one by yourself. Just a heads up, this isn't the exact same level of question. So a person measures the angle of depression from the top of a wall to a point on the ground. The point is located on level ground 62 feet from the base of a wall, and the angle of depression is 52 degrees. To the nearest tenth, which means I have to go out one decimal place, how far is the person from the point on the ground? So let's first go through and label our picture. Okay. So I know that my angle of depression is 52 degrees. So remember, our angle of depression is up top. But if you remember in the notes on the front, What we said was that our angle of depression is the exact same as our angle of elevation. They're actually congruent to each other. So I already have one piece of information. So let's go through the problem one more time. A person measures the angle of depression from the top of a wall to a point on the ground. Let's just make this our point. Let's make this our point. The point is located on level ground 62 feet from the base. So this is 62 feet. Okay. And the angle of depression is 52 degrees. To the nearest tenth, how far is the person from the point on the ground? Okay. So I want to figure out how far. So what I want to figure out is, one second. So what I want to do right now is I'm drawing my person up top, and I want to figure out this length right here. So now we need to label. This is my hypotenuse because it's across my right angle. This is my opposite because it's across from my reference. And then this is my adjacent. So if I look at my picture, I have information about my adjacent and my hypotenuse. So adjacent and hypotenuse deals with cosine. So cosine of 52 is equal to my adjacent over my hypotenuse. I now go one step further and say cosine of 52 equals 62 over x. In a lesson from a few days ago, we learned that when we want to solve, we cross multiply, so we get x cosine 52 equals 62. But here's the issue. X cosine of 52 is not a number, but cosine of 52 is. So the inverse of multiplying by a cosine of 52 is dividing by a cosine of 52. So my cosine of 52's cancel, so I get x equals 62 over cosine of 52. And I just type that into my calculator. I do 62 divided by cos of 52. And I get 100.7. That is your final answer. So what I would recommend is make sure you watch this video at least one more time since this is a little more challenging. Answer the 2 independent practice questions. Remember, your independent practice questions will now be due on Fridays at 11:59. But to make sure you're pacing yourself, what I would do is make sure those 2 IP questions are due tonight. Don't submit them until Friday. But if you want, you can have them checked by myself or Miss Kimmick. Again, I do have office hours today, so if you have any questions, please don't hesitate to reach out. Hope you're staying safe. Don't forget to answer that one question. Write down one question you have about this material. All right, have a great day.